Okay, finishing up where we left off, I've defined E to be the limit as n goes to infinity of 1 plus 1 over n to the n. This is some notation which we're going to talk more about next week, but basically what I'm saying is that as n, this is just a different way of saying that as n goes to infinity, the expression 1 plus 1 over n to the n approaches some particular number, and we call that particular number E. Okay, so this is pretty exciting. I want to talk about two things, or three or four things actually. First of all, as I was saying, there is some kind of inherent tension if you look at the expression 1 plus 1 over n to the n. You should sort of think about this. What happens to this expression as n goes to infinity? Well, first of all, if you raise a number to a larger and larger power, then that number is going to get bigger and bigger. So on the one hand, this n seems to be making this number bigger and bigger. But on the other hand, if you raise a certain number to a certain power, and that number at the base is getting closer and closer to 1, then you would think that the power would be getting closer and closer to 1. Okay, what am I talking about? We can do some sort of examples. Suppose I take a number which is only a tiny bit bigger than 1, like, I don't know, 1.01 for example, and we raise it to the nth power. What happens to this as n goes to infinity? Well, this is going to also go to infinity. Because, well, to multiply something by 1.01, if you multiply something by by something more than 1, it's going to get bigger. This is going to keep getting bigger and bigger and bigger. This is like 1% exponential growth, but this will eventually grow very, very, very big. On the other hand, if I take 1 plus 1 over n to the, and pick a very large number, like, I don't know, 2,000 or something like that. So what I'm now doing is I'm taking a number to a very large power. And generally speaking, you're going to think of that as being really, really big. But if the number that you're raising to the power of 2,000 is getting closer and closer to 1, then you're really just, as this gets closer and closer and closer to 1, you're really just multiplying 1, or a number tiny bit more than 1, by itself 2,000 times. And a number that's only a tiny bit more than 1, even raised to the 2,000 power, is still not very big. In fact, it's going to be very close to 1. And so what you have here is as n goes, this is sort of like an understanding of this expression, as n goes to infinity, on the one hand, this n is saying make this bigger and bigger and bigger and bigger, whereas this n is saying make it closer and closer to 1. And the answer is we settle at about 2.71. Okay, that was the first thing I wanted to mention. The second thing I wanted to mention is that there is an alternate notation for E. And this alternate notation is often kind of useful. And so what we can do here is we can do a limit switchy. And we can define a new variable like a. So we can say, alright, let a be 1 over n. And here I'm taking the limit as n gets really, really big. Well, as n gets really, really big, what happens to this new letter a? Well, a is going to get really, really small. And since this is true, a different but totally equivalent way of talking about E is that E is what you get, and now I'm going to translate all the symbols from this sentence into new symbols involving A instead of N. So this is going to be, instead of writing 1 plus 1 over N, I'm going to write 1 plus A. And instead of writing to the N is now 1 over A, so I'm going to write this as 1 over A. And instead of taking the limit as n goes to infinity, now what's A is going to 0. And so this is an alternative definition of E. Both of these are useful. Okay, last thing to wrap up this Precalc B review involves the so-called continuous compound interest formula. So as we did as we did in class just a little bit ago, I think that kind of works. Whoa. As we did in class a little bit ago, we had this formula for the amount of money we should expect at a certain time, and we say the amount of money we should expect is the principal times 1 plus r over n to the nt. That is our formula. And now the question is, well, what happens to this amount as the number of compoundings approach infinity? So we need to answer the question, as n goes to infinity, what happens to p times 1 plus r over n to the nt? And if you look at this, it seems like e should be involved in this somehow. In fact, I sort of like see kind of like an e in there, because that's 1 plus, kind of like 1 over n to the n, and we know that that is the definition of e, but not quite. And the problem is that there's this sort of annoying r. And so what we need to do is we need to get that r out of there. And how can we get the r out of there? Well, we need to sort of like get that thing away. And one thing we might do is replace r over n with another variable. Like say, I don't know, m. So let m be r over n. Why would I do such a thing? Well, you'll see. So if m is r over n, well, as n goes to infinity, what happens to m? M goes to 0. 0 plus, actually. Okay, and so now what I'm about to do is I'm about to rewrite this statement, just like we did a minute ago. Instead of n, I'm going to use m. So the answer to this question is the same as the answer to the question, what happens as m goes to 0 to p times 1 plus, and now I defined this new variable m to be r over n, so in place of that r over n I'm going to write an m. And in place of this nt, okay, well I have to be a little bit careful now. What is n? Well, if m is r over n, then that means nm is r, and that means that n itself is r over m. Yeah. So over here I'm going to write r over m times t. Okay, and now what I can do is I can write this a little bit differently as p times 1 plus m to the 1 over m times r times t. And then by exponent rules, this is really just p times 1 plus m to the 1 over m, that whole thing to the RT. And so what we see is that the answer to what happens to your certain amount of money if you leave it in the bank for a certain amount of time and a certain interest rate is that as m goes to 0, this 1 plus m to the 1 over m, that's the alternative definition of e that we just made from 5 minutes ago. And so this entire thing here inside the brackets, as m gets closer and closer to 0, that expression gets closer and closer to e. And so what we have is p times e to the RT. And this is kind of a derivation of the thing that you learned in Precalc B, which is if you have a particular principal and a particular interest rate, and you so-called compound continuously, in other words, you let the number of compoundings approach infinity, then the amount of money you're going to have at a certain period of time is going to be p times e to the RT, where t is the number of years the money has been invested. This is the so-called continuous compound interest formula. Okay, that ends our review of Precalc B E stuff.